Section 4.6 has to do with functions. Here's the definition of a function. A function is a relation in which each element of the domain is paired with exactly one element of the range. In other words, none of the x's are repeated. A relation is a function if it passes a vertical line test. So there's two ways to see if something is a function. Maybe you have a set of ordered pairs. You got 2, -4, and you've got 3, 5, and you've got -1, -4, and you've got 2, 7. And I go, is that a function? Well, I look at the x values, and I notice that this and this are the same x value. So this is not a function, okay? Now, the y values can be repeated and have it not be a problem, but the x values cannot. But if you have, let's say you have a graph and you don't even have any functions, and you're trying to decide whether what you have is a function or not. Let's say I have that graph. If I dropped a vertical line test down here, it would hit this in more than one spot. So this is no, it's not a function. But if I have this graph, and I drop a vertical line test down, it only hits it in one spot. So this would be yes, it is a function. So look at these and determine whether they are functions or not. This one, the -2 goes with the 2, the 0 goes with the 1, the 0 goes with the 4, and the 1 goes with the 3. Notice how the 0 goes to two different numbers. So I have a 0, 1 and a 0, 4. So this is not a function. I look at this one, look at all my x's. None of my x's are repeated. So this is a yes, it is a function. This one, oh, I've got a repeat on the x's right there. So that's a no. This one, if I drop a vertical line test down, it intersects it here and here. So this one is a no. Remember, it has to pass the vertical line test. And to pass the vertical line test, it has to only hit your graph one time when it goes down through it, okay? Obviously, if I drop the vertical line test over here, it wouldn't hit it at all. But if at any spot it hits it more than one time, then it tells you it is not a function. I do have function notation, which just simply says you can take an equation that's written as y is equal to 3x minus 8 and write it as the f of x is equal to 3x minus y. So this f of x takes the place of that y. If you wanted to find the value of y, if x was 2, you could use function notation that looked like this. This simply tells me to substitute 2 in where the x is. So 3 times 2 minus 8 gives me a 6 minus 8, or a -2. It's like what we were doing on the tables earlier. We put the value of x in and solve for the y. So here we find that the y is -2, so we would have a ordered pair of 2, -2. It told me what the x needed to be. They're not always numbers, sometimes there's letters, so let's practice some of those. If the f of x is 3x minus 4, find each of the values. So this is telling me to plug in 4 where the x is. So 3 times 4 minus 4 is going to give me 12 minus 4, which is an 8. So that would be the answer of the f of 4. This is going to tell me to plug in a -5 where the x is. So I have -15 minus 4, which is a -19. Now this one's a little weird because it tells me to plug in 2 minus x where the x is. So I'm going to go ahead and write the equation, and I'm going to put a parenthesis where the x is. So I wrote that equation, put a parenthesis where the x is, and substitute it in 2 minus x in the parentheses. I'm going to have to do distributive property, so I have a 6 minus 3x minus 4 is going to give me a 2 minus 3x. This one's a little bit more complicated, but you're doing the exact same thing. Everywhere there's an m, I'm going to put a parenthesis, just like I did up there. So I want to substitute negative 3 everywhere there's a parenthesis. So this is going to give me a 9 plus 12 plus 5. So that's going to be a 21 plus 5 is a 26. This one, do the same thing, but this time in my parenthesis, I have a 6z. Remember, I have to square the 6 and the z, so it's 36z squared minus 24z plus 5. Okay, so that's my answer for the k of 6z. Now, this one looks way more complicated, but it's not. I'm going to do the inside first, and it's going to tell me to substitute the y everywhere there's an m. So I have a negative 4 on the outside, which I get from right there, and this is going to give me a y squared minus 4y plus 5. Then I just distribute by multiplying my negative 4. So that's going to give me a negative 4y plus 16y minus 20. And that's going to be my equation for the negative 4 times the k of y. All right, your homework is page 229 through 230, 18 through 42 even. Let's see if I can focus in on that. There we go. All right.